So let's get started. Again, welcome everyone. I'm glad you're all on time. We have a large group of people. We're probably going to have more than 200 people today. Very, very excited. So I'm going to do a quick introduction of Create and Learn. I know many of you have taken our classes, so you probably know already. So this will be brief, and I'm going to introduce Winnie. Then we're going to get started. Okay. With that, I'm hand the presentation to Winnie, and she is going to start her talk.
All right. Hi, guys. Hi, guys and girls. I'm Winnie Lamb. I'm really pleased to meet you here. And I'm so excited that you guys are so enthusiastic with chatting away, hearing about your favorite sports and your favorite games. So I'm really excited to be here. We're going to make the next 50 minutes or so of this class very interactive. So I want to see you guys answering lots of questions, raising your hands, chatting away. All right, so let me now share my screen. All right, guys. Okay, so here we go. So who here uses the internet? Chat away. I want to see all your responses. Who here uses the internet? And that's almost a trick question. You'll hear why in a second. Yeah. Okay, so everyone is saying yes, yes, yes. Okay, everyone uses the internet. Me, I do. Okay, well, you know what? We're all using the internet right now. If it wasn't because of the internet, we wouldn't be connected here. So yes is the right answer. Okay, so as Jessie said, I have been at Google for 15 years, and that might be before a lot of you were born, if not all of you. And so I'm excited to share with you what I've learned from Google and from working in the internet industry. All right, so what do you think is needed when you play a game on Minecraft with your friends? What do you think happens when you watch a YouTube video or search on Google? I want you guys to chat away and tell me what you think. Okay, I'm seeing lots of great answers here. So Wi-Fi is needed. Yep. The internet is needed. The web. Yep. Lots of programming, lots of coding. Wow, you guys are amazing. You can type a lot faster than I can read. Okay, we need servers, we need the web, we need batteries, we need data transmission, Java, ATMs. Okay, I would be very curious to hear why you guys think we need an ATM. Okay, amazing. Thank you for all the answers. Well, all of you guys are right, because here are some basic components of what we need from the internet when you're playing games online with your friends, when you're watching a YouTube video, when you are doing a search on Google. These are the things that you need, right? So first of all, we need internet access, because you need to have connectivity between what you're doing at home, on your phone, on your computer, to the broader internet. That's how we get connected, is through that internet access. So that's number one. Number two, we need lots of code, right? Because we need the code to tell us how do we figure out what is the most relevant video to show you when you're doing a search on YouTube. Or if you're doing a Google search, we need to figure out what is the most relevant answer to your question that you're asking Google. So we need all that code. Some people call these software algorithms, and I saw some of those answers that you had texted on the chat box. So yes, we need lots of code. And of course, we need computers, right? We need these computers that is housing the software that, that tells all these algorithms what to do. So all these components are needed. And you guys are very creative in telling me many, many other things too. You're saying that we need computer chips. That's right, because we have computer chips inside those computers. And a lot of these computers are rightfully, as you had pointed out, called servers. A lot of these really powerful computers are called servers. Now, some of you might be using a phone to play games. Some of you might be using a desktop computer at home. Some of you might be using a laptop at home, and those things are all correct. What happens is in a broader setting, when we are supporting all these activities, we need much more powerful computers, and those are often called servers. Okay, all right. So I'm really amazed at all your answers. Okay, let's go to the next question. Okay, so now we have lots and lots of kids who are all playing online games and watching videos at home all at the same time. What do you think we need to make that happen? Let's see some answers here. So now we're going from not just one person watching a YouTube video, but we're doing all the kids around the world. They're all playing games, they're all watching videos, they're all sending emails, they're all chatting away like you guys are doing. Yep. So you need friends, you need supercomputers, you need data, you need internet, you need internet, you need routers, you need devices, you need money. Okay. All right. Well, all of you guys are right. So let's go to the next one. I'm going to show you now a picture of lots and lots of these computers being together. So this is a picture from a facility that puts all of these computers together. So in these places, we need a lot of internet access, a lot of internet connectivity, and we need all these computers all working together. You can see in the picture that they're all wired up, they're all connected to each other. And so there's a name that we use to call the buildings that house all these computers and all this network equipment. And those buildings are called data centers. So now I have a question for you. In these data centers where we have all these computers, how many computers do you think we have in one data center? 1,000, over 9,000, 100, a lot. Oh my God, a bajillion, a million. Oh my gosh, you guys can type a lot of zeros. Okay, that's pretty incredible. I have never seen so many zeros before in my life. Wow, okay. A lot of nines too. Okay, well, so depending on how big the data center is, you can either have, lots of computers, maybe hundreds. In really, really big data centers, you can have thousands, many thousands, hundreds of thousands. So it really depends on the size of the data center. Some data centers, like I said, the smaller ones, they don't have, millions of computers, whereas some other facilities that are larger, they would have lots and lots of these computers, all supporting the types of software that we were talking about before. And like I said, as you can see, there are all these cables, all these wires running between the computers to keep them all connected to each other, because all these computers need to work together in a distributed fashion. Okay, you guys are really smart. I love it. And I love the participation. Please keep it going. All right. So the next thing I'm going to show you is that some people call these data centers server farms. Now, the term server farm seems to imply that it's like a farm, right? A farm has animals like cows and goats and plants and people growing vegetables and things like that. Do you think that we can grow a data center on a farm with soil and water? Okay, I'm seeing a bunch of no's. I'm seeing some yeses. I'm seeing carrots. Okay, most of you guys are saying no. And guess what? You are right. You cannot grow a data center on a farm with soil and water. So even though some people call these facilities server farms, they're not actually a farm like what you would see to grow carrots or to grow vegetables. A data center is really a facility with all these computers, and you cannot grow computers with soil and water and sunshine. So a different kind of farm. All right. So now I'm going to show you a video of what a data center looks like.
Whenever you use a Google product, you're connecting to one of our data centers around the world. Let's take a look inside and see how they work. Google employees work here, keeping the data center up and running 24 hours a day. The networking room is the first stop on our data center floor. The equipment here routes requests to the right servers in the next room. These computers also allow our data centers to communicate with one another globally. On the server floor, Powerful computers handle everything from billions of searches to hosting YouTube videos and protecting your email against viruses. We've custom designed these servers to be compact and energy efficient. To ensure you have access to your data whenever you need it, we keep each piece of data stored on at least 2 servers. We store another copy of the most important data on digital tapes. When a hard drive breaks, we erase all of its content. Then, for extra security, we destroy it with our disk crusher. The machines in our data centers are always working. Cooling towers like these pipe in water to cool them down and keep them running. When the water heats up, we pump it back outside where it evaporates. Now that you've had a glimpse, walk inside yourself. Explore a Google data center with Street View.
All right, so hopefully that gives you a glimpse as to how data centers work. All right, so now do you think data centers are really big buildings or do you think they're small? Big, big, really big, giant, really, really big. Okay, well, you guys are right. Let me show you the picture of a data center. Now, this is a data center hosted by Facebook. Facebook, you might have heard, is the social media, social networking site. And so this is the picture of Facebook's data center in Ireland, in Europe. And you can see that it is ginormous, right? So you can see in the picture that the buildings in the back of the picture, those are the data center buildings that house all those computer servers. Now, in the front part of this picture, closer to where you are, that is where you have what we call a substation. That is where we put a lot of electrical equipment to support all these computer servers. And you can also see in the picture there, we have some transmission towers. These are the power equipment that bring the electricity over to a data center. So as you can see, it is really, really ginormous. You know, that is the size of football fields, if you know what football is, you know, like in the Super Bowl. So data centers are ginormous, huge, huge places. Okay, another question for you guys. Where do you think data centers are located in the world? Where are these places? California. Okay, empty land. In the USA, in remote places, in Ireland, in China, in Silicon Valley, in America, on a farmland, in Virginia, in Greenland, in New York, in Alabama, in Korea, in pineapple. Okay, all right, so you guys are all right. But let me, before I answer the question, I want to give you a couple of hints. So I got the next question for you. Do you think data centers are in your backyard? No way. Yes, maybe. Okay, do you think data centers are on the cloud? Like, is it up in the sky, in the cloud? I see some yeses, some no's, some possibly. Some people are not sure. They think that there's a satellite somewhere. Somebody said it would fall if it's up in the sky. All right, so now let me tell you the answer. Theoretically, you could fit a data center in your backyard, but chances are it's not going to be there. Is it physically located in the cloud? Not really. We don't, you know, put like a data center on the clouds in the sky. So data centers, as you saw in the video, they are located on land for the most part, although some people are experimenting with putting it in the ocean. But for the most part, I would say 99.9% of the time, these are giant facilities that are on land in vast pieces of land where you can find a lot of space. Now, let me show you a world map. This is a map of Google's data centers around the world. And you guys know what a world map looks like, I hope. And so what we're seeing here is that Google has data centers all around the world. In the USA, like many of you had mentioned. We have data centers in South America. We have data centers in Europe. And we also have data centers in Asia. So we have all these data centers around the world where each of these red dots represents a physical data center somewhere in the corner of the universe. So now I want you to tell me in the chat box which Google data center is the closest to you. Okay, the one in North Carolina, yep. The ones in the USA, the ones in Oregon, yep. In Illinois and California, okay. Well, I know that the letters here on the slide are a little bit small for you to see. Many of you are correct in that we have data centers in Tennessee. We have some on the West Coast in Oregon. We have data centers in other parts of the world that you're closer to. So you can see that these data centers, let me show you another picture of data centers by another company. So this is Amazon. Who here has heard of Amazon? The online company, not the Amazon jungle. Me. Okay, all of you guys have heard of Amazon. And so you and your family probably get packages from Amazon because you're doing online shopping. Well, when you're doing online shopping with Amazon, you're really using Amazon's website. And that website is supported by Amazon's data centers because those are the computers in Amazon's data centers that process your request of what you want to buy. And so this is a world map of the places where Amazon puts their data centers. And so you can see there in the blue dots and the red dots are the places that are coming soon. So they also have data centers all around the world, a bunch of places in the United States, in South America, and in Europe, and in Asia and Australia as well. All right, so next question. How do you think companies decide where to put a data center? Based on population? No idea, okay. Based on where they can find a lot of space, where it is the cheapest, where it can reach people, where there's good weather, you want to put them in cold places, where it's safest, where a lot of people live, where you can get refunds, where you can pay less taxes. Okay, all right, well, you guys are really onto something here. And somebody also said that their dad used to work at Amazon. Pretty awesome. Well, let me ask you this other question. Now, Amazon, Google, Facebook, and Microsoft, they don't have data centers in the North Pole or the South Pole, where the polar bears and the penguins live. Why do you think that is? Because it's too cold, because there aren't many people in these places. Nobody lives there. It's too hard to manage. There's no internet there because they hate penguins. Too cold because of the magnetic field. All right. Well, you guys got it right. So there aren't really many people in the North Pole and the South Pole. I mean, we have scientists who do research in the North Pole and the South Pole, but there aren't really that many of them. And so for these companies like Amazon and Google and Microsoft and Facebook, they'd rather put data centers where there are a lot of people. And so you guys got it right. Well, but polar bears and penguins, do they need access to the internet? Like, what if the penguins want to order pizza? Okay, well, we'll figure out that question another time. But most of you seem to think that penguins and polar bears probably don't need the internet. Maybe someday they'll figure out how to order pizza on the internet. But until then, so these are the things that we consider when we decide where to put a data center. And a lot of you guys already said the answers to these questions. So the first bit is we need access to the internet, right? And in places like the North Pole and the South Pole, internet connectivity is just not as good, right? We tend to put more internet connectivity where there are a lot of people. So that's number one. Number two, electricity prices also really matter in terms of where companies want to put the data centers. We're going to talk about this a little bit more later. And a lot of you also already said money. Money matters. You know, let's face it, companies do care about money. So electricity prices matter. And then a lot of you also said this, you know, in the North Pole and the South Pole, there aren't many people there. So in the data centers, we need people to work there. And polar bears and penguins, they can't really do the jobs that we need in a data center yet, not until after we train them. And we also want to put data centers in places that are close to people who are using the internet. So all of you guys who are playing online games at home, all of you guys who are watching videos at home, you want to be closer to where these data centers are, because that's where you can get faster, a concept that we call latency, which is you want to minimize the amount of time that you're asking for the internet to do something and for you to get it back. Because let's face it, you guys wouldn't like it if you're wanting to watch a video and then that spinning wheel just keeps spinning and spinning and spinning, and you're waiting for your video and it's taking forever to come. I mean, that kind of sucks, right? So we want to put the data centers really close to where people are. Okay, all right, so these are the important factors for us to consider. Now, running a data center is very different from running your computer at home. So when you're using your internet at home, you might be on your laptop, on your iPads, or on your phones. Well, you saw the picture before that in a data center, you have all these computers all running at the same time. And so running these facilities is really quite different. Okay, so running a data center requires a lot of energy. Why is that? Why do we need all this energy? Because we need to compute data, because we need lots of power. There are a lot of machines running at the same time. We need good Wi-Fi. We need to connect. We have high demand from these computers. Yep, we need lots of electricity, lots of Wi-Fi, need solar panels. Okay, so there's a lot of power that's necessary. Okay, well, I mean, you guys have all seen this before. You know that when you're using your phones or your laptops or your iPads or your computers, you have to charge them, right? Because, let's face it, we've all had the scenario where, we're running out of juice in our devices, and, and then our computers stop running, so we have to charge them. And when we charge them, we're plugging them into the wall at home or at school, and that requires a lot of electricity, right? And so that's only when you're using your one phone, your one laptop, or your one tablet. But imagine if you have these bajillion number of computers all running at the same time, like we're gonna need tons and tons of energy to power them all at the same time, right? And so imagine, the equivalent of having, thousands and thousands of these plugs happening all at the same time. Okay, so that's why we need a lot of energy. So the next question for you is, where does electricity come from? From power plants, from flash, from lightning, okay, from under the earth, from the sun, from water, from wind farms, from solar panels, from the sky, from fossil fuels, from McDonald's, okay, from your body, from anywhere. Okay, all right. Well, you guys are all right. So let me show you where electricity comes from. Okay, so this is a picture of what we call the power flow, all the way from power plants down to your house. So we're going to start on the left side of this picture here. So we have power plants that generate electricity. And as a lot of you have already said, we have these power plants that use fuel sources that might come from natural gas. It might come from hydroelectricity. It might come from coal. It might come from a wind farm. It might come from solar panels. So there are all these different ways in which power plants generate electricity. And we can talk maybe another time about how power plants generate electricity. A lot of the plants that use, let's say, hydroelectricity or natural gas, they're using turbines, these big, huge pieces of machinery that exist in the power plants, and they convert those energy sources into electricity that you and I can use at home or at school, or if you're parents, at work. Okay, so we have all these power plants that are making the electricity. Now, to get the electricity from the power plant down to your computer, there are a lot of steps that need to happen in the process. So the next step after the power plant generates electricity is that it goes to a transformer that increases the voltage for that electricity. Now, some of you have learned lessons in your science classes about electricity and voltage, but basically increasing the voltage increases the efficiency that you can pass on electricity from the power plant eventually to your home, so that you're losing less of the electricity in transit. Okay, so we're stepping up the voltage in the transmission. And then we have these transmission towers, you know, that crisscrossy picture that you see in the middle. We have these transmission towers that are carrying the electricity over very long distances from the power plants to your house, because most of us do not live right next to a power plant. So we need these wires, these transmission lines, and these transmission towers to carry that electricity from the power plant to your house. Do more transformers to step down the voltage to make it more usable at the voltage levels necessary in your homes. And then we have these distribution power lines to send that electricity to your house, so that eventually when you're plugging in your computer into the wall, into the socket in the wall, you're getting that electricity that really came originally all the way from the power plant, which tends to be very far away from your house. So that's how electricity gets to your house. And that's how these data centers housing, you know, all these thousands of computers are getting their electricity as well. Okay, so now we know that data centers use a lot of electricity. How can we make them environmentally friendly? Penguin power, okay. Solar panels, okay. Water, geothermal, wind, use less electricity. I like that. Water, okay, okay. Nuclear, oil, recycling, okay. Toilet paper, All right, so you guys are really creative, and you are absolutely right. So we can use renewable energy. Renewable energy are things like solar power and wind power that converts the power from the sun. So we're taking in all these sunlight, and we're absorbing them into the solar panels, which is made of a material that can convert that sunlight into electricity. And then similarly, with a wind turbine, you can take the energy from the wind to spin the wind turbines, and then that through a process, we can create electricity that way. Now, some of you are also really smart in telling me that you can also have other environmentally friendly sources. There's geothermal energy that I hadn't talked about here in this picture. Geothermal energy is where you're tapping into the ground, because the ground, when it's really deep below, tends to hold a fairly constant temperature. And by using that geothermal energy, you can also tap that as a very clean source of power. Some of you also talked about nuclear power. Nuclear power is not the cleanest form of power, but it is a carbon-free form of power, such that when a nuclear plant is running, you're not emitting carbon emissions into the air. Unlike the case for a coal power plant or a natural gas power plant, where when they run, you are emitting carbon emissions into the air, which is not great for climate change, is not great for global warming and things like that. There are other ways of generating electricity in a clean way as well. Some of you mentioned water. Hydroelectricity is yet another way to generate clean power. Although it is, you know, there are people who like it and there are people who don't like using hydroelectricity, because what happens is when you're using hydroelectricity, you're putting turbines usually in a river, and that helps you generate electricity through a bunch of turbines as well, in a very similar way as a wind turbine or even as a gas turbine. But the reason why some people don't like hydroelectricity is because when you're putting those turbines in a river, you're really blocking the movement of the fish and all the other animals that live in the rivers. And so because of that, it is, you know, it does have some environmental consequences. Now, I also like what some of you said, which is we can do recycling and we can use less energy to make these data centers more environmentally friendly. And so the less energy you use, the fewer solar panels you need, the less electricity you need from a coal power plant, for instance, or the less electricity you need to run the wind turbines. And generally speaking, using less energy is a very, very good thing. So being energy efficient is a good thing. Another person here said that you can recycle. Guess what? In these data centers, we generate garbage too, right? When you're done using a computer, we have to figure out what to do with it. And so we recycle a lot of the used computers that are no longer running. If a computer breaks, we have to recycle it. And so those are some of the ways in which we can make these data centers more environmentally friendly. So I really like all of you guys' suggestions here. Okay, next question for you. In these data centers, we don't always install solar panels and wind turbines on that same vast plot of land, though. Why do you think that is? It takes up too much space. It's expensive. Takes up a lot of space. Yep. Too much to maintain. It's money. It might not always work. Gets too hot. Okay, well, you guys are absolutely right. So in a data center, because it uses so much electricity, we're going to need a bajillion solar panels or wind turbines to power and provide all the electricity needed to power the entire facility. And, even with such a big place like the data center is, and you saw the picture before, it is difficult to have enough solar panels or enough wind turbines in the same facility to power all those computers. So that's one reason. The second reason is that a lot of times the places where we put data centers, they're not in the sunniest places, or they're not in the windiest places. So where the places that are optimal to put a data center, meaning that they have the best internet connectivity, we have the best people who can work there, and all those things that we talked about before, it may not be the best place to put a solar farm or a wind farm. So for those reasons, we don't always put them at the same place. And finally, the people that we hire to work in a data center are not always the same people with the skills necessary to run a wind farm or a solar farm. And so those are some of the reasons why we don't always put solar panels and wind turbines in the same facility. But there are many ways in which we are buying solar energy and wind energy to power these data centers. I'm not going to go into that topic today too much, but for Google, for instance, all of the energy that we use in the Google data centers are being matched by 100% renewable energy, by wind energy and solar energy, etc. Okay, all right. So my next question for you is that computers get really hot when they run, but not as hot as this. The computers don't explode and get on fire like you see in this picture, but they do get hot, right? Sometimes when you're running your computer, you might notice that your computer is getting really hot. So how do we cool them down? Use fans, we can use water, we can blow. Okay, you can let air under it. You can use ice, a ventilator. Okay, all right, you can take a break. That's right, you can shut it down, turn it off, use air conditioners, use liquid cooling, use an ice pack. Okay, all right, well, all of these are correct answers. So we can do a lot of things. Certainly if you turn it off, we'll definitely cool it down. Now, in the case of data centers, we want to keep the computers running all the time because there are people, wanting to buy things from online stores like Amazon. There are people wanting to, play online games. So we try not to turn off the computers altogether, but there are many ways in which we can cool them down. Let me show you one picture. So what happens is in a computer, it often lets out the hot air through a fan. Many of you guys said fans, and you're right. We have fans that blow out the hot air. And so what we do is an idea called separation. So we want to separate the hot air from the cold air. So where all these computers are blowing off the hot air through their exhaust, we want to keep all that hot air together in a closed space so that we're keeping all the hot air together. And then we want to supply these computers with colder air so that they're not stuck in this really warm environment. So it's this concept of separation, keeping the hot air away from the cold air. And so we have different spaces where we can do that kind of enclosure. So that's one way that we can use to cool down the computers. Now, many of you also said water or use an ice pack, and you're also right in saying that. Because we can use these things called cooling towers. So let me explain this a little bit. So when we're blowing the hot air off of those computers, we can use water pipes. So, pipes carrying a lot of water to pick up that heat that's coming out of those computers, so that the water, when you're picking up all that heat, the water becomes really warm, right? So it's taking away the hot air that came out of those computers. So now you have this water that's getting warmer and warmer, and we have to cool down that water so that we can eventually cool down these computers as well. So now, when we send it to these mechanical equipment, they're called cooling towers. The way a cooling tower works is that you can bring into the cooling tower this warm water, and then the cooling towers are evaporation machines. Evaporation means that you're really letting the hot water kind of blow off, if you will, so that the warmer water gets evaporated. It goes into the air, and then what ends up happening is that you get left with the cooler water as a result. So all the hotness in the water gets evaporated into the sky, and you have the cool water left. And then you're sending that cool water back to the computers so that we can cool down the computers. So that's how cooling towers work. And cooling towers are really not only for data centers, they're used for other places too. At your school, I've seen many schools that use cooling towers in the summertime too, when you're needing to cool down the school. Now, what some of you also said is use air conditioners. We have things like air conditioners in data centers too. They're called chillers. So, using water is a very energy efficient way for us to cool down these computer servers. So I love how you guys, can really teach this course now. You have all the right answers. All right, so another question for you. Based on everything that we discussed, what are the jobs that exist to make the internet go? I mean, I kind of already gave you some answers on this picture, but I want to hear from you too. Okay, we need hackers, we need engineers, we need technical writers, lots of software engineers, lots of coders, developers, we need Bill Gates, we need programmers, we need exploiters, we need plumbers, and memory people. Okay, you're right. So we have many different types of jobs that make the internet go. So we didn't talk about it too much today, but we certainly do need software engineers. These are the people that are doing the programming, or these are the developers that are writing all of that code to figure out how we can find things on the internet, to figure out if you're wanting to shop for, I don't know, a robot. How can you find a robot? How can you buy it on Amazon or something like that? So these are the people who write the software, write the code to do all those things that you can do online. So they write the software algorithms. Well, we also need hardware engineers, because you saw in the pictures, we have all these computers running inside a data center, and someone has to design, what do these computers need to look like? Do we need a lot of memory? Do we need a lot of storage? Do we need, really fast gaming cards? What kind of components do we need in each of these computers? Because to do different things, we need different components sitting inside these computers. Now, we also need network engineers. As you can imagine, when millions of people are all using the internet at the same time, there's a lot of requests into the network, and these network engineers figure out how to send those packets of data in a distributed way across all these thousands of computers in a data center, so that the information gets back to you as quickly as possible. they figure out that if, let's say you live in California, should we be sending your request to the data center in the West Coast of the US, or should we be sending it to Asia? Or should we be sending your request to Europe? So these are the network engineers who figure out how to answer your questions as quickly as possible. We also have technicians who work inside the data centers, right? Before we talked about the cooling towers, we talked about how much electricity we need inside a data center. These technicians, they design the equipment, they design and they maintain the equipment that live inside all of these data centers to make sure that they're always working. In case the power goes out, which some of you have experienced at home sometimes, if you have no power at home, what do? Does the data center go down and stop working? These technicians, they figure out how to keep the data center up and running all the time, even in cases where there's a disaster or some sort of an outage. So many of these people work in the jobs that are necessary to make all your online games work. Okay, all right. So, so we learned a lot of stuff today. We learned how the internet works a little bit. We learned where data centers are. We learned why we put them where we put them. We learned how to make them environmentally friendly. So now I'm going to open it up for questions and answers. And raise your hands or chat and tell me if you have any questions.
So Winnie, if you click on the button that says Q&A, there are a bunch of questions there. You can just answer there.
Okay, all right. First question from Pranav, did I make any Google games? Well, me personally, I didn't make any Google games. I worked in the team for Google Search that figures out how to give you the answers to your questions. I worked on the team that does advertising, which makes money for Google because we need money. I worked in the team that makes the data centers as well. Okay, is Google interconnected with YouTube? Yes, YouTube is a part of Google, and all the YouTube videos live inside of Google data centers. Okay, how many server farms are there in the world? Wow. Well, there are lots of them. I showed you the pictures of where Google and Amazon's data centers are. Like I said, Facebook has data centers, Microsoft has data centers, and many companies also have data centers. Now, some companies run their own data centers, and so, they don't use a data center from, Amazon or from Google. Instead, they maintain their own data centers, at their office building or something like that. Okay. Are there a lot of people in a data center? Well, there are definitely people who work in a data center, but guess what? There are many more computers in a data center than there are people. Okay. Do data centers cost a lot of money? Absolutely. They cost a lot of money. Many millions of dollars. Because these computers cost a lot of money. Now, when you're buying so many computers, they cost a lot of money. It costs a lot of money to build all those buildings. It costs a lot of money to bring all that internet connectivity to a data center. Okay, Chase asked me, do I make a lot of money? Well, Chase, you're gonna have to find out if you do the same job that I do. Then you'll find out how much money I make. Okay. Okay. Naman asked a good question. Why do people step up electricity when later they step it back down? Well, it really has to do with the efficiency of transmitting all those electrons. So when you're stepping up the voltage from a power plant to the long distance transmission power lines, making the electricity higher voltage makes it more efficient. And what more efficient means is that you lose fewer electrons along the way, because you lose some electricity when you're sending it from one place to another. And then later on, you have to step the electricity back down to the right voltage for your house, because your house runs on a different voltage that's much lower than what it takes to run in those high voltage transmission lines. that's running for long distances. Okay. Gabe asked a question, how are power plants made? Well, it depends on what kind of power plants they are. If it is a solar plant, then you have a lot of solar panels and you have wires that connect them together. You have inverters that convert between DC and AC, direct current and alternative current, alternating current. You have different power plants, like a natural gas power plant or a hydro power plant. Those are all run differently. And without going into it in too much detail today, you can find many videos on YouTube that tell you how the turbines in those facilities work. Okay. Luke asked a question, what makes a power source environmentally friendly? That's a great question, Luke. So environmentally friendly would be that it doesn't emit a lot of carbon. And so what you might have learned in science class is that when there is a carbon being emitted into the atmosphere, it traps greenhouse gases. And when you're trapping greenhouse gases, you have the effect of warming up the earth. And that's creating some of the global warming effects that we're seeing. And so carbon emissions or those greenhouse gases would be more environmentally friendly. And because wind farms and solar farms do not emit carbon emission sources, when they're running, that's what makes them more environmentally friendly. Okay, next question. Okay, let's see, there are similar questions that I'm seeing here. Okay, are you a robot or are you just really good? I am a robot. I am not a real person. Someone created me a long time ago and I was made by a software engineer. Okay. Okay, Lakshmi asked a question, wouldn't water destroy the computers? Very good question. So when we're using water to cool down the computers, we make sure that the water is not spilled or leaked to the computers because, Lakshmi, you might be thinking that, well, what happens if I spill water on my laptop or on my phone? It stops working. Well, we don't want that. And so we want to make sure that when the water is carrying all that hot water to the outside world, that it is not being spilled to the machines so that it wouldn't break the machines. Good question. Okay. Chanu09 asked me, when did I join Google? I joined Google in 2004, which was 15 years ago. That was quite some time ago. Somebody else asked me, have I ever been a software engineer? Well, I studied engineering at the University of Waterloo, and I have taken courses on software programming. I have done some of it, but I went pretty quickly into doing other things in technology at Google, working on the technical infrastructure side that I talked about a lot today. Okay. Okay, how much money do I earn from Google? You guys are gonna have to get jobs at Google to figure that out. Okay, what if for some reason the computers in the data places break? Good question, Michaela. So if the computers break, there are many ways that we can fix them. It depends on what it is that the computers are broken. So if, let's say, someone wrote some software, and let's say there are some bugs in the software, we can always push out updates to update the software. And sometimes you see this on your phones too, right? On your Android phone or something like that, it says software update now ready, and you have to push a button to update that software. And so, that's one way for us to update the software. Now, if the hardware breaks, if a computer is broken and we need to fix the hard drive, or we need to change out the memory or something like that, we can take out that computer out of service, we can fix it and then put it back into service. Do I enjoy my job? Yes, I really like my job. All right, well, Jesse, I know that we're running out of time here, so I know there are many, many more questions here, but maybe I'm gonna hand it back to you and pause it here.
Okay, so we did promise the student that a couple of them going to get a chance to ask live questions. Do you want to pick maybe 2 or 3 people to see if anyone still want to ask live questions? So for those of you who want to ask a live question, you can raise your hand and Winnie will be able to see it. But if you don't want to ask live questions, don't raise your hand. And as I mentioned at the beginning, if you do, your voice will be recorded and your voice will actually be on YouTube, okay? If you don't want your voice to be on YouTube and your parents don't want your voice to be on YouTube, make sure you don't raise your hand. Okay, so Winnie, do you want to just maybe pick like 2 or 3 people to see what questions they have?
Yes. All right, Michaela, you're on the line. Let's hear from you.
How many people work at Google?
Okay,
How many people work at Google?
how many people work at Google? So Google has over 100,000 people working around the world. So that's a lot of people. That's I'm sure many more people working at Google than at your school. All right, Matthew, you're also on the line. What's your question?
Are you actually a robot?
What do you think?
No.
That's right. I'm not a robot. I'm a real person. I need to eat right after this because I'm hungry. Okay, Jaden, you have a question.
Have you met Bill Gates?
I'm sorry, Jaden, can you say that one more time?
Have you met Bill Gates?
Who?
Have you met Bill Gates?
Oh, Bill Gates. You know, I have actually seen him in real person, like once before. I was at an energy conference, I want to say a year ago, and Bill Gates was giving a talk about clean energy. And so I didn't get to shake his hand, but I have met Bill Gates once before. All right, Dia, you have a question.
Are the data centers open during coronavirus lockdown?
Yeah, so are things open during the coronavirus lockdown? Well, our data centers are still absolutely running all the time right now, which is why you can still, search on Google, you can still send emails, you can, watch videos on YouTube and things like that. And so we work really hard to keep our data centers up and running so that people like you can use them at home. All right, maybe just one last question from Archit.
Do you work at the search bar thing in Google?
Yeah, so I worked in Google search some time ago, a long time ago. And at that time, my project was to make Google's, what we call the index bigger so that you can search for more and more things from Google. All right.
Thank you. Those are wonderful questions. And you guys were so engaged for the whole class. That was awesome. I hope you guys all enjoyed it. And we are going to send the questions you guys asked to Winnie. If she has time, we might answer some of them. But for those of you that, in case you haven't, you missed the beginning of the talk or you want to see this again, we're actually going to share this in on YouTube probably in a few days so you can see it there. We'll also send an email to your parents when the video is up. I also want to make sure that everyone is aware this is actually a series of talk. Today is the very, very first one. So thank you, Winnie, for coming in and gave a talk. That was awesome. You guys did a great job. You can see classes like from people that works at Apple, people who are at Stanford University to talk about all sorts of different things. And this is a website to go to, create-learn.us. That's our company's website. /open class is where you can see all the classes coming in, and all the classes will be like this. There will be hundreds of people attending, which is super fun, and then we can all interact. And here are actually 2 of the talks I mentioned coming up. One of them has to do with art and computer science, and the other one actually has to do with all the genome stuff. And they actually going to, the team of people from Stanford actually going to tell us how you can, by playing a genome related game. Maybe you can help solve the coronavirus problem as well. That one is super fun as also. And then I know many of you have taken our classes, but in case you haven't or you want to do more of it, you can also always go to our create-learn.us website to sign up for free introduction classes on coding, Minecraft coding, Scratch coding, artificial intelligence. We run many of those classes every single day. And then so you're welcome to join anytime and tell your friend about it as well. So that's it. If you do have questions and feedback, we will actually send a survey out also. We love to make this better. And so, and also tell us what else you want to hear in the future. Okay. All right, I think with that, we're gonna wrap up today. Thank you again for everyone for attending. And thank you, Winnie, that was awesome, really, really cool. And I'm sure everyone enjoyed it.
Awesome. All right, well, good spending this time with you guys. Bye.
Bye.